So in this section, we wanted to talk about the multiplicative inverses of matrices and matrix equations. So the objective of this section will be find the multiplicative inverse of a square matrix. Okay, this is a very important thing. If it's not a square matrix, you do not have the multiplicative inverse. Okay, so use inverses to solve the matrix equations and encode and decode messages. So this is a very important technique using linear algebra. Yeah, and then which is also what in what cyber security. This means if you in the future if you wanted a computer science job, this will be very useful. That is the basic encoding and decoding. Okay, so the multiplicative identity matrix. So the n by n square matrix with ones on all the diagonals at upper left, upper right are all zeros. They are called what? Multiplicative identity matrix. We use I to represent the identity matrix. I2 means 2 by 2. I3 means what? 3 by 3. So for the identity matrix, it's always what? A square matrix. So it's always n by n. Okay, so that's one definition. So the definition of multiplicative inverse of a square matrix. So let A be an n by n matrix. So if there exists n by n matrix A inverse, so A negative 1 A inverse, such that A inverse equal to In, A inverse A equal to In, then A inverse is called what? Multiplicative inverse. So this will tell you, so because if you have a different order, so if you have m times n and n by p, yeah, and then what happens here? Your p has to be equal to m too because it's n times p and m also times n, yeah, so p has to be equal to what? M2. Are you with me? Okay, otherwise you cannot do you cannot do the multiplication. This is why they always use what? Square matrix. They always use what? Square matrix. Okay, so you can, okay. So if a square matrix has a multiplicative inverse, it is said to be what? Invertible or non-singular. Okay, so when will it have be invertible or non-singular? When the determinant of A is not equal to what? 0. I think this will be, later on we will introduce this too. Okay, so that B is a multiplicative inverse of A. Okay, B is a multiplicative inverse of A. Then what do you need to check? A times B, or it has to be what? The identity matrix. Do you remember how to do the multiplication matrix? The first row, first column give you this number, and then your first row, second column give you this number, yeah, okay, and then similarly, the second row, first column give you the bottom one, and then you can calculate. But do not forget, it's not only A times B. You also need to check what? B times A. Yeah, so in the previous sections, we know that AB may not be equal to BA all the time. Okay, so that's a very important technique. Okay, a very important check. You have to check both AB and BA is the identity matrix. Okay, so then it's multiplicative inverse. Okay, and so a quick method to find the multiplicative inverse of a 2 by 2 matrix. So what it will be? A, B, C, D. Okay, so A inverse, what it will be? So you keep, so interchange the diagonal. Okay, so your A and D you interchange. And then what? Opposite the other two. Okay, so this is how I remember. Okay, so what will you do? You make a matrix, interchange the diagonal, and make the other two numbers opposite. And do not forget, you have to 1 divide AD minus what? BC. What is AD minus BC? That is also what? Determinant of A. Yeah, so the determinant of A. Okay, so this is the formula for the what? Inverse. Okay, so now let's look at some example. If you have 3, 1, -1, -2, what will you do? You make the diagonal, yeah? So interchange the diagonal. What it will be? 1, 3. And opposite the other two. So 2, 1. So this is interchange, yeah? These two are what? Opposite. Okay? And then what will you have? AD minus what? BC. So AD minus 3 times 1 minus -2, -1. So it's 1, yeah? So what do you have? Like this. You with me? Yeah. Okay, so find A inverse for, this is what? For 2 by 2 matrix. Find the A inverse for n by n matrix if A inverse exists. Okay, so what will you do is you form the I augmented matrix A at In. So where In is what? The multiplicative identity. And then what will you do? You only perform what? Row operations. Never perform what? Column operations to obtain a matrix of form INB. Okay? Then matrix, so it will be matrix B will be the A inverse. And you can also check your answer here. Okay, so what should we do? Okay, so the book, has all these methods. So what I will do, I will show you, work with you step by step. 1, -1, 1, 0, 2, -1, 2, 3, 0. You have 1, 0, 0, 0, 1, 0, 0, 0, 1. Yeah. Okay. So what should we do to make this one to be 0? So your R1 plus R2. Are you with me? So R1 plus R2. You have what will you do? You keep the R1 the same, yeah? Keep the R1 the same. So your R1 plus R2. 1 plus -1 will give you what? 0. 0 plus 2 is what? 2. 2 plus 3 is what? 5. 1 plus 0 is what? 1. 0 plus 1, 1, 0. Okay? In order to save some space, we wanted to do the same thing to get rid of this one here. What will you do from here? Okay, so because this is 1, this is 1, what will you do? You wanted the negative R1, yeah, plus R3. Negative R1 plus R3, what happens? -1 plus 1 is what? 0. -0 plus -1 is still -1. -2 plus 0 is what? -2. -1 plus 0 is what? -1. Is the remaining keep the same, yeah? So, do not forget it's everything plus -1, yeah? Okay, so then what should we do? We wanted to make this a 1, yeah? But do you remember? We can also interchange, R2 and R3, because here is -1. It's much easier. Here is 2. 2 is okay, but here is 5. You will get what? Fractions if you make times 1/2. Are you with me? That is too hard. So what will I do? I will interchange R2 and R3. What will you get? 1, 0, 2, 1, 0, 0, 0, -1, -2, 1, 1, 0. and what do you have? 0, 2, 5, 1. No, not 1, 1, 0. Okay, be careful. Is okay, so you guys, do not be like me. Okay, so it means the whole row. Yeah, so negative 1, 0, 1. Yeah, so it's 1, 1, 0 for the whole thing. Okay, so then what should we do? We wanted to make this to be what? 1. Yeah, so we wanted what? Negative R2. Yeah, so what we'll have? 1, 0, 2, 1, 0, 0, 0, 1, positive 2. Yeah, so all the positive become negative become positive, and then positive become what? Negative. Yeah, so then you have 0, 2, 5, 1, 1, 0. Are you guys okay? Yeah, so then the next thing we wanted to do is what? To get rid of this 2. How could we get rid of this 2? So is what? Negative 2R2 plus what? R3. Yeah, so what do we have? 1, 0, 2, 1, 0, 0. So because we only do R3, so the first 2 rules we keep it the same. So it's 0. So 1 times negative 2 is negative 2 plus 2 is 0. Negative 2 times 2 is what? Negative 4 plus 5 is what? 1. Aha, that's the best. Yeah. And then negative 2 plus 1 is what? Negative 1. Negative 2 times 0 is 0 plus 1 is still 1. Yeah. So it's negative 2 times negative 1 is 2. 2 plus 0 is what? 2. You with me? Okay, so now what should we do from here? What should we do from here? We get all the bottom to be 0. Now we wanted to get the upper half to be what? 0, 2. Yeah. So what should we do here? You want to get rid of this 2, get rid of this 2. Yeah. So what will you do? You use backwards. Yeah. Use the R3. So is what? Negative 2 R3 plus what? R2. So what will we do? We keep the R3 the same. So we copy it down. We do not change it. So negative 2R3. So this is 0. Because here is 0, does not change anything. So negative 2 times 1 is negative 2 plus this 2 is what? 0. So then negative 2 times this negative 1 is 2 plus this 1 is what? 3. Negative 2 times 1 is what? Negative 2 plus 0 is what? Negative 2. Negative 2 times 2 is what? 4. Negative 4 plus this negative 1 is what? Negative 5. Yeah. So then, we wanted to do negative 2R3 plus R1 too. Yeah. So because you have another 2. So the same thing. You have 1, 0, do not change. Negative 2 times 1 cancel this 2. So negative 2 times negative 1, 2 is also 3. Negative 2 times 1, negative 2. So here is not negative 2. Negative 2 times 2, negative 4 times plus 0 is negative 4. Perfect. Okay. So now we have the identity I3 by 3. Yeah. And what will be done on the right side? That's your what? A inverse. Yeah. So what will be your A inverse here? 3, negative 2, negative 4, 3, negative 2, negative 5, negative 1, 1, 2. You with me? So what will be the check? You have to check A inverse, and after all these things, you wanted to what? I3 by 3. And you also need to check what? A inverse A and equal to what? Identity matrix I3 by 3. Okay, so that's very important. Okay, so that's very, very important here. Okay. Okay, so I will not do the multiplications. Yeah, so you guys can try. So because that's what row, column, and you do it carefully. Okay, so you can follow, you can see, okay, so you have the same answer. And what will you do? A inverse, yeah, and then you multiply again. You do it, carefully. So we will do 1 with you. It will be what? 1 times 3 plus what? 0 times 3 plus 2 times -1. So it's 3 minus 2 is 1. So this is how you get the 1. And then similarly, you get all the other numbers. Okay. So then summary, how could you find the multiplicative inverse for invertible matrices? If it's what? 2 by 2, the inverse of A is given by this special formula. Of course, you can also use the method on here to find 2 by 2, but typically if you remember the formula, it's easier. But if it's what? More than 2, 3 by 3 or 4 by 4, okay, so it will be easier use low transformations to find A inverse. It will be easier. Okay, so it's this one. Okay, so the next thing we wanted to do is solving the multiplicative inverse. So equations. Okay, so it will be AX here equal to B. Yeah, X here is a matrix too. Okay, X here is also a matrix. Okay, so you guys need to be careful. Oh yeah. Okay, so X here is also a matrix. If A here is n by n, yeah, what will be the X? It has to be have n rows, yeah, so it will be n by 1 matrix, yeah. So what will be B? Is also a matrix n by 1 because okay, so then you can do the multiplication according to the definition. Okay, so if Ax equal to B has a unique solution, then X equal to what? A inverse of B. This is what? A inverse, yeah, so A inverse is not A minus B, yeah, so it's A inverse and B. So what do you want to find X? You want to find A inverse and then do the multiplication of matrix. Okay, so let's look at one example. Okay, so what will we have here? You have 1, 0, 2, -1, 2, 3, 1, -1, 0. Yeah, so this is the coefficient of our xyj's. So times xyj, yeah, so this is a very important way to rewrite the matrix. Yeah, so what does this mean? So if you have x plus 2j, yeah, think about this. The first row times what? The column, what do you get? It will be what? 1 times what? X plus what? 0 times y plus 2 times j, yeah. Okay, so you only have one column, and then what do you have here? Second row times first column, it will be on the second row, yeah, so it's -6x plus what? 2 times y plus 3 times j. And then you have what? 1 times x minus 1 times y plus 0 times j. So equal to what? 6, -5, 6, yeah. So when will two matrices be exactly the same? Is everything be the same? This is how you get it, yeah. Yeah. So if you are given a linear system, how could you write the matrix form? This is how you write, yeah. So you put all the coefficients 1, 0, 2, -1, 2, 3, and 1, -1, 0, and then you write x, y, z and one column that is like a special n by 1 matrix, and then write all the numbers on the other side. Okay, so this is the matrix form. Okay, so what will be the x? We all know from the formula x equal to A inverse will be. Okay, so then how could we find A inverse here? Yeah, so Yeah, so we have already found it in the previous example. Yeah, so then what will we do? We use this A inverse and then times what? 6 negative 5, 6. And you get your solution x, y, j here. Are you guys clear? Okay, very good. Okay, so a cryptogram is a message written so that no other. This is the application for coding and decoding. Yeah. So, to encode a message, we begin assigning numbers to each letter. A equal to 1, J equal to 26, and the space equal to 0. The numerical equivalent of the message is converted into a matrix. Okay, so what will you do? So express the word or message numerically. List all the numbers in step 1 by columns and form a square matrix. So you form a square matrix in columns. Okay, so like the example they use is base. Yeah, so that will be like BASE. Yeah, so BASE, so it will be BASE here. Yeah, okay, so then what will you do? You select any square invertible matrix, call it coding matrix. This is the matrix that you wanted to give your partner. Yeah, so this will be the only coding matrix, and then you multiply the coding matrix by the square matrix, and then it will give you a totally different thing. And when the other people know the coding matrix, and then can reverse it, maybe decoding it to obtain the message. Okay, so how could we encode the word base? So from the formula itself is what you write the base in what columns, BASE. Yeah, okay, so what will we do? We multiply. Yeah, so -2, -3, 3, 4, you multiply 2, 19, 1, 5. Yeah, are you with me? Then you do the multiplication. So what do you have? -4 plus -3. What do you have? -7, -38, -15, -53. And 3, 2 is 6. This is 10. 57 plus 20 is 77. Yeah, so this is the matrix that you were sent. Okay, but for the matrix that you use in code, you are only to tell your partner, not anybody else. Yeah, so this is the matrix that is encoded. Okay, encoded. Okay, so the result is, so it's this. So what will you send the message? It will be -10, -7, 10, -53, 77. So it has already encoded. Okay, so but if you wanted to pass this message out, you have to send the encoded message. Also tell your partner the square matrix that you are using. Okay, really good. Okay, similarly, how could you decode? Okay, so what will you do? From the you have to find the inverse of the coding matrix. Yeah, from the coding matrix they give you, find the inverse. And what will you do? You find in the multiplicative inverse of the coding matrix, and also the coded matrix. That will give you the other matrix. Yeah, so if you want to decode this, what will you do? I think this is the first step is to find the inverse. Yeah, and then to write the decoded matrix in columns, and then multiply the A inverse. Yeah, you guys okay? Yeah, so A inverse is 1 over 80 minus BC, D negative B negative CA. Yeah, so you interchange the diagonal and make it opposite on the other two. Yeah. So then you will do this thing, decoding, add to 195, and you will know that this is what base. So you have decoding the word. Okay. So that will be this section.